Hello sir, I am Yogesh. I am from the MTech department. I am here to talk about the cognitive dimensions. We can see them elaborately. A warm welcome to the today's gathering as we delve into the intricate realm of the software architecture. We can specifically exploring its cognitive dimensions and in the ever-evolving landscape of technology, we must understood the cognitive dimension of the software architecture and it's a paramount one. And it goes beyond the code and the algorithms. And it delves into how the humans perceive and the humans understand and interact with the software system. Today we will delve into topics such as mental models, problem solving strategies, and the cognitive blasts that shapes our approach to the software architecture. We will explore this how the cognitive factor influence design, decision, system usability, and ultimately the success of the software projects. By understanding this cognitive dimension of software architecture, we empower ourselves to create systems not only for the system efficiency but also resonate with the users on a deeper level. We can enable us to design the initiative interfaces, anticipate user needs, and the foster seamless interaction between the human and the machine. Now we can see about the topics which come under the cognitive dimensions one by one. The first one is the interdependency. The interdependency in software architecture it can refer to the relationships or connection that between the components of knowledge that are not explicitly documented from the system design or documentation. These dependencies can manifest in various forms and we can have a significant implementation for the system maintenance, usability and the understanding. Here there are some common examples of the interdependencies. There are implicit function calls, implicit functions called shared state, implicit function called shared state and the runtime dependency and the incremental dependency. The the interdependencies can interview the interdependencies can introduce several challenges in software development and maintenance. And they are debugging, maintenance, and testing. The debugging, which can the, sec- the second one is abstraction. The abstraction is a fundamental concept in software engineering and computer science, and that involves simplifying complex system by the focusing on high level concepts while hiding implementation details. It allows developers to manage complexity, improve code reliability, and facilitate problem solving by creating models that can represent the essential aspects of the system. They are the key aspects of abstraction. They are generalization, high complexity, encapsulation, reversal abstraction, and the data abstraction. The premature commitment. The premature commitment in software development it refers to making decision or committing to specific design choices or implementation. Before that, having sufficient information or understanding of the problem domain, and it can occurs early in the development process, and they can lead to the suboptimal or even detrimental outputs later on. The key aspects of the premature commitment is the limited the limited understanding, the rigid solution, uh, uh, early optimization, ignoring alternatives, and the increased risk. The fourth one is a secondary notation. The secondary notation that refers to the additional supplementary symbols, annotation or markings that are used by alongside primary notation to convey the specific information or enhance understanding in various fields. They are including mathematics, computer science, and the music and the engineering. While the primary notations serve as a main symbol or representation of the concepts or data, the secondary notation provides additional context and clarification and the metadata to aid the interpretation or analysis. Some examples of secondary notation in different domains. The mathematics in the mathematical expression, the secondary notation such as parentheses, brackets are used to indicate the grouping of terms and the order of the operations. Then the music notation, the secondary symbols such as accidentals, dynamic markings, and articulation symbols, they provide information about the pitch, tempo, like that. And the third one is the computer science. In the programming language, the secondary notation like commands, annotation, and metadata, they are used to provide context, explanation, or documentation in the for code segments. The fourth one is engineering. In engineering drawings and schematics, the secondary notations are the dimension, lines, and the annotations, and symbols they are used to provide measurements, specification, and additional details about the components. The fifth one is the viscosity. In the context of software engineering and programming, the viscosity refers to a measure of the resistance or difficulty of making changes to the code base or the system. It reflects how easy or difficult it is for developers to other to best practices. They can implement the new features, fix bugs, or make improvements without introducing errors or breaking existing functionality. And they can manifest in different forms. They can include the code viscosity, development environment viscosity, and the cognitive viscosity. The code viscosity. This code viscosity refers to the resistance that encountered when they're trying to modify or refactor the code due to complexity or tight coupling. And the high code viscosity often results from the poor design and the excessive dependencies. The development environment viscosity. This can refer to the obstacles to inefficiencies in the development environment that can hinder productivity and makes it more difficult for developers to perform their task efficiently. And the third one is cognitive viscosity. This can refer to the cognitive overhead or mental burden experienced by developers when they try to understand or navigate or modify. The sixth one is visibility. In the software engineering, the visibility can refer to the accessibility or the scope of a variable, methods or the classes, or it can other programs the elements within a code base. It determines where and how these elements can be accessed or manipulated by other parts of the program. The visibility is crucial for ensuring proper encapsulation, modularity, and maintainability of the software systems. There are four levels of visibility that are defined in a object-oriented programming language. The public visibility means that a variable, method, or a class is accessible from any part of the program. It can include in the external modules or other packages. The private visibility restricts access to a variable, method, or a class to only the one containing the class or a module. The private elements cannot be accessed in here. The protected visibility allows access to a variable or method from within the same class or from its subclasses. And the package visibility, it is also known as a default visibility. It can't restrict access to your elements within the same package or the module. The element with package visibility are accessible only to the classes within the same package. The seventh one is the consistency. The consistency in cognitive dimension that can refer to uniformity and predictability of the design process and the interaction within a system software. And it focuses on ensuring that similar action or elements that can behave consistently across the different parts of the system, and then they are allowing users to develop the mental models and effectively that can navigate the interface. The consistency is a fundamental principle in user interface design and is closely related to the usability and the user interfaces. And when the system exhibits a consistency in its cognitive dimension, that the users can more easily learn how to interact with it, and they can perform tasks efficiently, and they can avoid errors or confusions. Eighth one is a diffuseness. In the context of cognitive dimension, it can refer to a quality of a system or interface where the cognitive load placed on a user is unnecessarily increased that can due to the excessive complexity and ambiguity or a lack of clarity in the design. The diffuseness is cognitive dimension that can hinder users that can ability to understand, interpret, and effectively that can interact with the system that can leading to a confusion, error, or a decreased usability. There are some key aspects of diffuseness in a cognitive dimension. They are complexity, ambiguity, information overload, and the lack of focus, and a cognitive dissonance. The first, the complexity. In the complexity, the diffuseness that can often arises from excessive complexity in the design or the structure of the system. The ambiguity, there is a diffuseness that can be manifest as ambiguity in the system's language, terminology, or a visual user that can lead to uncertainty and the misinterpretation among users. The information overload. The diffusions can result in an information overload where users are inundated with the excessive amounts of information or options, then making it challenging to focus on relevant content or make informed decisions. The lack of focus, it can make cause a lack of focus in the system's design where users are presented with too many distractions or unlimited elements. The cognitive dissonance, the deficiencies that can create cognitive dissonance where users encounter conflicting or contradictory information that can be arise from the inconsistency in terminology. It's a progressive evaluation. It is a concept in usability testing and evaluation that involves continuously assessing and improving a system or an interface through this development life cycle. The, the traditional usability testing, which typically occurs at a specific milestone or after the system is fully developed. The progressive evaluation emphasizes ongoing evaluation and its iteration to identify and address usability issues early, and the iterative improves the user experiences. They are the key aspects of the progressive evaluation. They are early and iterative, and the incremental improvement, and the flexibility and the adaptability, and the integration with the development process, and continuous learning and improvement. To implement the progressive evaluation efficiently, the teams can use a variety of usability that can testing methods and use, including heuristic evaluation, usability testing sessions, user interviews, and surveys. By combining qualitative and quantitative data from multiple sources, the teams can gain a comprehensive understanding of the usability of the system. The last one is the provisionality. The provisionality in the context of a cognitive dimension, it can refer to the flexibility and adaptability of a software system or interfaces to the accommodate changes, experimentation, and exploration by the user. It also involves providing users with the ability to explore the different options, and then they try out new features and customize the system to serve their preferences and their needs. There are some key aspects of provisionality in cognitive dimensions. They are the flexibility, experimentation, feedback mechanisms, customization, and the iterative design. The provisionality in cognitive dimension is essential for the creating software system that are responsible to users' the changing needs, preferences, and the context of use. Providing flexibility, the systems can empower users to explore, adapt, and the innovative that can lead to the higher levels of engagement.